So before starting right now, just before 2 minutes, the light has been gone off. So we are delayed because of that, the 2 minutes. But if certain circumstances happen, please bear at least 4 to 5 minutes because we have to shift from myself from PC to the laptop and then continue forever. So if it is there, please bear us for that same one. Now, let us start with the introductory part. We know that from the very humankind, from so many millennia, uses the people stone and timber for the construction purpose as a building material for the structural point of view. And since from last 200 years, the steel and concrete is very, very popular, and there are so many buildings, so many types of the structures which has been constructed by using these two materials, specifically the steel and concrete. So the modern urban landscape is to be defined basically on the steel and concrete, if you can say roads, sewers, highways, buildings, bridges, and many, many complex infrastructures which has been made up specifically on the steel and concrete. Now, as we know that the world's major population, most populations which depends on the major extensive infrastructure system, we know that are what we know. But when we are using this infrastructure system and those infrastructure systems which has been made it out specifically the material steel and concrete, then definitely because of the limitations of each individual material, there will be a deficiency will be generated. The deficient because of the certain reasons, and because of the certain reasons, we have to think that how we can prevent this deterioration, and if the deteriorations will be there, then what to do for those structures. So as the one of the best solutions and lasts for 20 to 30 years, the FRP, that is the fiber reinforced polymer material, has a more gaining popular as far as the civil engineering is concerned. But as the history shows, that the literature review shows that FRP is mostly to be used in the aerospace industry as well as the mechanical engineering. But now it has a gaining popularity as far as the civil infrastructure application is concerned. And the reason behind is that the FRP cost has been decreased. Why the question of FRP cost has been decreased? We can say that if, even though I belongs to right now one of the small city of Gujarat, even though the nearby surrounding area of 180 kilometers, the FRP product has been manufactured in the industry. It is the true thing. So it means that what happens the past scenario, that some of the companies has been made it out the FRP, but now there are various companies are there where they are making the FRP. So hence, because of that, the cost has been decreased. So now there are certain reasons that lead to degradation of the existing structure. And one of the reasons is of the corrosion. We know how the corrosions will be taken care. So I'm not that much discuss the corrosion, what is exactly to be going on. But the final product has been seen over here, what really happens and how the strength has been decreased because of the corrosions has been shown with the end results. Another reason for the deficiency in the existing structure is one of the environmental effect, like wet and dry conditions, freeze and throw conditions, and because of the some of the reasons is fluoride ingress in the existing structures, and the existing material will behave and the deficiency will be generated. The another reason that the evaluation of the existing structures needed and the deficiency will be generated because of the updated design laws, and also the updated design procedure, and also the existing, because of the population increases, because of the new developments are there, the traffic will be heavier, and because of that the existing structures will become deficient. Another reason, as I told, the traffic will increases. These are the certain reasons the deficiency will be generated. This deficiency will be generated because of the seawater as shown in the figure. These are the certain deficiency. How the end cap devaluation as far as the bridge is concerned. See the various images. and specifically the earthquake will lead. The damage is in the existing structure. So there are two types of questions may arise in our mind that why repair, restrengthening or retrofitting will be carried out with the same material. It means why it is to be carried out with the steel and the concrete itself, and why we are going to repeat the cycle. The same scenario, if we are doing the repairing material with the same thing, then the similar kind of the deficiency may be generated. Why? So why we are not switching to the another new material, innovative material, as we know that is the FRP material, and because of the certain advantages like the first, that is a light weight. Because of the lightweight, and we can say that it is very lightweight in comparison with the concrete and the steel is concerned, so that it is very easy for us to install anywhere. It is having a high strength. I'm going to show you the next slides in which it will be clearly shows that it has having a very good high strength and approximately 5 times than the steel. Obviously, it is a corrosion resistance. Corrosion resistance with respect to certain one. When we are discussing in the same series about the durability aspect, you can see that the certain FRPs may lead to some of the corrosion extent with the certain chemicals are concerned. But majority, the corrosion which will be taken care to a steel in that extent, the FRP which is not corrosion one, means it is a durable one. Also, it is a highly versatile material, means it is to be used for any kind of the project and at any place you can put it out. Now, there are certain reasons what the needs of the composite. As we know that the composite is the material which is a combination of more than two materials, two or more than two materials. So the one of the reason here it has been stated that it has having a high strength and stiffness, means the FRP which is having a very high strength and stiffness to weight ratio, and approximately it is 2 to 10 times strong as the steel plates, while the weight is approximately only 20% of that of the steel. And this property enables the thinner section designed for the longer span, as well as ease in the site handling for layman labor is concerned, and that will reduces the labor cost also. Weight reduction adds the seismic resistance, it adds to speed erection and saving in the cost of constructions due to reduced weight cost of the structure. As I stated earlier, it has a high corrosion resistance. Also, it has a non-magnetic property. It is having a low creep, better fatigue life, because the creep and fatigue are the two different words we have frequently used as far as the concrete is concerned. But here for the FRP having a low creep and better fatigue life, having a better thermal properties, having a lower maintenance cost, and important thing, it has having a flexibility of shape. And because of that, it is possible to produce FRP products in the various shapes and sizes like cables, rods, flat bars, panels, reels, fabric, sheets. So this offers a great flexibility as far as the shapes and size which are to be concerned. One typical stress strain diagram which has been shown over here, and clearly it has been given a comparison with respect to steel also. It is to be clear visualize that for the FRP here, three different types of the FRP which has been shown over here: glass FRP, armored FRP, steel FRP, carbon FRP. Another which is also available, ballast FRP, but here has not been taken care right now. But you just see it is having a straight line relationship as far as the stress versus strain is concerned. While for a steel, it is a slightly, not slightly, major ductile behavior will be seen after the yield point. So there is an advantage for the FRP is concerned that it has having a higher capacity to resist a load and very high load carrying capacity to resist. But the disadvantage, you can also visualize that the ductility part is concerned, that the steel which is having a ductile material, while the FRP is which is nothing but a brittle material. So here one typical properties has been suggested or shown over here. The same thing which we discussed in the previous slide. The one important thing that for the FRP properties having a lower strain at failure, which lead it is to be as a brittle behavior. So what is FRP? FRP is not a single material, but it is a composite material which is a blend of the high strength, high moldous fiber and hardenable liquid matrix. Means it is a summation of the fibers plus matrix is concerned. So fibers and matrix resins, their physical and chemical properties are to be discussed over here, because fiber has its own property, the matrix has their own properties, and when we combine together, the property is slightly different than both of the constituent material. So the bonding of the aligned fiber by the softer matrix results in the FRP composite material, which is superior properties specifically in the fiber directions if we are applying in the existing structure. So exactly definition of the FRP is the materials which is created by the combination of two or more materials on a microscopic scale to form a new and useful material with enhanced properties that are superior to those of the individual constituent alone. We know the certains of the composite material like concrete. Reinforced concrete is also one of the composite material. That is concrete in steel itself. Wood and our bone are the composite material. Similarly, FRP is also a composite material. Now, in this FRP, the 50% to the 65% which will be carried by the fibers part and the remaining part by the polymer resin matrix. Both the material has their own usefulness, own uses in the composition in the composite is concerned. Like the fiber reinforcement carry the load in the design directions, and the fibers being the main load carrying constituent give FRP its strength. So the question may arise, what will be the responsible for the strength? That is, in FRP is nothing but the fibers, while the polymer resin matrix having a less load carrying capacity, and resin acts as a medium to transfer the stresses between the adjoining fibers through the adhesion, and also provides the protection for the material from the UV and chemical damage. So here, one thing is to be noted, that polymer resin matrix doesn't provide the load carrying capacity, but it provides the bonding. It provides the bonding between the FRP and the older construction. So it is also one of the important one. We can't say that only fibers are important, but there is a polymer resin matrix having their own value over here. And whenever there will be a certain failure will be taken care, then this polymer resin matrix will become a weak link. And as we discussed over here, somebody has opened their microphone. So your microphone open for you, Chef. So now, what is FRP? As we discussed, and in that the two parts are there: fibers, another is matrix. As matrix protects and transfers the loads between the fibers. The three types of the fibers has been written over here: glass, carbon, amide, and the matrices has been three types which are shown over here. We will detail discuss in the next slides about the types of matrix. Now, the typical fiber FRP stress strain behavior which has been shown. So here you can see that if an individual fibers are concerned, if we can say that the individual fibers are concerned, it is having a higher load carrying capacity. Just see with the first line which has been written by fibers, while if we take the matrix is concerned, having a very low load carrying capacity. So when we combine the two things, fibers and matrix, then we get an FRP having an intermediate strength, not to be more than fibers, not to be less than matrix, but then an intermediate strength we can gain over here. Now, the polymer matrix component, which is having the critical functions, the first, it will bind the fibers together, it protects the fibers from the environment and abrasion, it separate and disperse the fibers throughout the composite, It transfers the force between the individual fibers. Very much interesting point and important point, that transfers the force between the individual fibers. So now, what is the polymer? Polymer is an organic compound comprised of the long chain molecules consisting of the smaller repeated units called monomers, and there are two types are there: thermoplastic and thermosetting polymers. This thermoplastic, if we are taking examples of polyethylene, nylon, polyamide, while the thermosetting polymers are nothing but the polyester, vinyl ester, epoxy. These are the certain examples. Now, if we take the first, because we explain the thermoplastic as a polymer, matrix polymer, then it is having an extremely stronger bonds within the chain molecules. So you just see over here that one image is that the along the molecules having the very higher strength, has a good strong bonds are there. But this chains which is to be held by weak van der Waals forces, and because of the weak van der Waals forces, the molecule can slide past one another on heating. So because of the heating, this will become non-stable. So the polymer can be reversibly softened, and hence it is to be not to be used currently in civil engineering perspective. But if we are going for the thermosetting polymers, this molecular chain cross-linked through chemical bonds. It is a good, stronger bonds along the molecules, but cross-linked through also a very strong chemical bonds are there, and hence they cannot be reversibly softened, and hence cannot be bent on site. So very less possibility at elevated temperature about the deterioration is concerned. So this is the material, that is the matrix, specific the thermosetting type of polymers to be commonly used for the infrastructures FRP, and that are nothing but the epoxies, vinyl ester, polyesters. So if we are, let us understand the first one is the polyester and its use, then what is the vinyl ester and its use, and one is the epoxy and its use. So if we take the polyester, which is inexpensive, which is easy processing and widely used for the FRP components, means just like we know that the railway track which is made up from the I section of a steel, similarly when you pass through the roads, you just visualize there will be a high tension line is going on, and there will be a fencing will be carried out. In certain places the fencing, the channel sections, or maybe the certain vertical angle sections has been shown, and it is not to be made up of the steel, but that is to be certainly made up with the FRP components. And as I stated, as far as I know, the Gujarat is concerned near about area, the various factories are there that they are making this kind of FRP components in the factory, and in that case they are using the polyesters. The vinyl ester is specifically used for the FRP bars. FRP bars means reinforcement is concerned. Reinforcement is concerned, it means that the reinforcement that we are using inside the concrete for the to get the tensile strength. So similarly, the FRP bars, which is last from 20-25 years old back, it is to be used from in the foreign countries for the manufacturing of the construction as the bridges are concerned. So FRP bars in which the vinyl ester has to be used, and the bars which has been made it out. It reduces the moisture absorption and shrinkage, but this is quite more expensive in comparison with the polyesters. Now, third one is the epoxy. This epoxy is one of the useful thermosets, that is the polymer resin matrix, as far as the retrofitting task is concerned, as is to be used in the wet layer application as well as the laminate fabrications, as it has outstanding adhesion and bonding characteristics, but it has a slightly higher cost in comparison with the polyester and vinyl ester. Now, as we discussed all these things that about the fiber component, definitely provides a strength and stiffness. The other properties of the fibers, as we know, having a low variation of strength between the individual fiber and having a stability during handling, and more or less having a uniform diameter. One of the typical macroscopic view of the fibers has been shown over here in this particular image. Now, generally three fibers commonly, but recently gained popular very well the basalt is concerned. So now, the factors which will influencing the fiber suitability at any of the project is concerned, that is based on the strength, stiffness, environment and durability, cost and the availability. The cost is one of the major influence criteria. And if there is no cost, then the strength is one of the influencing criteria. Now, if we just likely study about the glass fibers is concerned, we all know as well as the concrete is concerned, the people are using the glass fiber as an individual adding in the concrete. That we are not discussing right now. The glass fibers, and because of that, the FRP, which the sheet which has been made up, that we are going to discuss right now, as it is inexpensive, means lesser cost in comparison with the availables. It is easily available in the market, and having the three types are there: E-glass, R glass, that is resistance type, that having a higher strength, moderate modulus, and medium density. And generally, this glass fibers FRP is used for the non-weight module critical applications. The carbon fibers, which is significantly higher cost than glass and the various varieties available in the market, but if we compare with the carbon glass and having a higher strength which is available, which is having a superior durability and fatigue characteristics and having a very high modulus. Another one is the armid fibers having a moderate to higher cost, and generally two different grades are available in the market: 60 GPa elastic modulus and 120 GPa elastic modulus. This is having a high tensile strength, moderate modulus, and the low density. But having some specific durability concerns are that it is to be generally degraded because of the ultraviolet rays, as well as there is a potential moisture absorptions in the swelling which will there. So there is a one typical comparison of the stress versus strain curve for the different fibers are concerned, and it is to be clearly visualized that as we proceed from armid E-glass and the carbon is having the highest stress stimulation, is having a higher strength carrying capacity in comparison with any other fibers. So as we discussed, the fibers plus matrix is FRP, but now as far as the structural application is concerned, the overall FRP properties that depends on the following factors. The one of the factor is nothing but the mechanical properties of matrix as well as the fibers. It also depends on the fiber volume fraction and the fiber cross-sectional area. The one of the important tasks that is to be done, the study is nothing but the orientation of fibers within the matrix. So this is one of the key factors, and the another factors are interaction between the fibers and matrix and the method of manufacturing. So how the FRP which has been manufactured is also one of the factor which will affect the final properties of the FRP, but one of the important key factors is nothing but the orientation of fiber within the matrix. Now, the influence of the fiber orientations and its specific use. As we know that the FRPs are orthotropic material, means it's directionally dependent. But in market, the various FRP laminates as far as the retrofitting is concerned is available. One of them is unidirectional FRP. Means in this case, the fibers are laying in one directions. That is, fibers in one direction is only aligned along the longitudinal axis. So during the structural use, we have applied those FRPs in such a way that we can use those strength. So it has having a stronger and stiffer in fiber direction. Now, if we switch to the multi-directional FRP, the laminates in here, the fibers various directions has been there to be manufactured that it is available majority in two directions. So the properties can be tailored and the behavior can be approached as an isotropic. Right now, even though it has been written over here that the unidirectional FRP is used in the infrastructure applications, but in certain cases, the bidirectional FRPs or multidirectional FRPs are also to be used for structural application. Typical image which has been shown the various types of FRPs and its components. Now, let us slightly discuss about the manufacturing technique of the FRP material. One of is the pultrusion process, and through pultrusion process, the FRP bars, structural sections, and the plates which has been made it out. One of the image which has been shown of the factory over here. Another is the weight layer application. Now, this is one of the specific tasks of the retrofitting or the re-strengthening is concerned. You can see that lay persons has been used FRP for carrying out the confinement of the column. There are once again the two types of the FRP sheet to be laid out. The one is the weighted FRP is directly available from the company or factory, and second one is the manual lay or laying of the epoxies and then application of the FRP on the column or beam. The another thing is the filament winding is one of the manufacturing techniques. From that, the FRP tubes, holes, tanks, and forms which has been made it out. Typical image which has been shown over here. Now, the FRP mechanical properties are the function, majority, repeat, majority, depend on this particular three. The one is the type of fiber and matrix. Second is fiber volume contained, and third one is orientation of fibers. So now there are some typical example applications has been shown over here related where is to be used, under which circumstances to be used. If you can say that for the flexure strengthening of a particular beam or maybe in terms of slab, it is to be applied at the tension and on the side face of the beam, and the fiber direction which has been kept along the longitudinal axis of the beam. As see the cross section of the beam very clearly showing over here. The shear. We know that the shear strengthening of the beam generally taken care near the support conditions and specifically on the side of the beam. So here also the FRP which has to be applied for the shear strengthening purpose on the side face of a beam, or certainly we can apply the U braid, and has to be applied here. The fiber directions are nothing but the perpendicular to the longitudinal axis of the beam. And for column, we have to go for the confinement of the column as shown in the schematic diagram. Certain typical FRP applications for the rehabilitations as well as the retrofitting is concerned has been shown over here. Clearly shows what is the application for shear is concerned, flexure is concerned, for beam and slab, and how the confinement for the column which has to be applied over here. The typical mechanical properties of the FRP sheets, specifically GFRP, CFRP, and AFRP, which has been shown over here, which has been taken care from one of the research paper, that is from JG10 et al. Here it has been clearly visualized that the tensile strength of CFRP and also the longitudinal tensile modulus is extremely high in comparison with the glass as well as armate fibers. Let us discuss about the installation technique. The first one is the wet layup application. Here, in case of the wet layup application used with the flexible sheets and saturated sheets with the epoxy adhesive can be applied on the flexible sheets under one or two coats, and that has to be placed on the concrete surface. Pre-cured sheets. As and when development is going on, the pre-cured sheets are also available in the market. Pre-cured sheets, just like as I told in the wet applications, it's a softer material. FRP sheets is just like a cloth. It's just like a cloth, that much softer is there. But here, the pre-cured sheets is a harder sheets which is available, having a certain own thickness, which is already pre-cured strips, and apply adhesive for the strip backing. See, the one of the typical applications has been shown over here. Some of the case studies which has been shown, this is one of the typical example of the FRP bars. But this is the one of the applications where the re-strengthening of the masonry wall and the RCC slab using pre-cured CFRP strips which has been used. Repeat, there is two different terminologies there, strip and sheet. Sheet is one of the very flexible terminology, and strip, which is then slightly thickness, it is slightly one kind of rigidity which is available in comparison with the sheet is concerned. Another one, a typical example which has been shown over here, that is the thing what the San Francisco City Hall building, which was retrofitted in mid-90s. You just see how much older one which has been retrofitted. Here, the basement of this building, which is included a number of hollow clay tile walls that were weak in shear. See the image over here. Another example is there over here. The application of FRP sheet at certain locations. So, upon the structural inspection during the construction phase, it was to discover that the several slab locations were deficient in negative moment flexion capacity. Hence, the use of advanced composite to retrofit the slabs was the ideal solution which has to be taken care due to large impact and conventional method of repair. So the FRP sheet was provided on the top of the existing slab locations to provide the required negative moment flexion capacity. One of the typical example, URM and partial concrete wall sections at the Palwar center of the arts at UC Riverside required to be additional shear strengthening due to corroded reinforcing steel and the spelled concrete. And the glass FRP was to be installed both horizontal and vertical directions to provide the required reinforcing as determined with the calculation. Now, let us go with the Indian scenario is concerned. Let us take slightly certain applications with respect to India is concerned. As we know that the humidity cycles accelerates the deteriorations in concrete, specifically in India, has monsoon within the 80% rain in the 2 months. So, because of this humidity region, there is a definite deteriorations to be taken care. The marine environment is the worst in India, which having a longer coastal line where the marine weather prevails. So in India, the structures required heavy repair within a decade of the constructions. As we know, how the construction is also to be carried out by the contractors also in nearby area. We know all are that. So the the deteriorations will be taken care in the near future after constructions. So there is a huge type of the availability of the strengthening as well as the retrofitting is concerned in India. So the overall composite markets in India is relatively small in comparison with the other parts of the world. A few years ago, the consumption level composites in India was only 30,000 metric ton as compared with the China of 2 lakh metric ton. So there is enormous scope of the use of the FRP in India is there, and right now it is being very, very popular and it's to be used also. There are certain few examples of FRP application for the retrofitting before Gujarat earthquake, but after earthquake, this technique is became gaining popular. And it is to be there that when we are using the FRP material, we have to use certain codal provisions. That with that particular codal provisions, we have to counteract that what is the size is to be FRP is required, what is to be length is to be required, maybe a 1 layer required, maybe 2 layer is required. So for that, certain guidelines are available from throughout the world, like American Concrete Institute, like FIB from sorry, FBI from the Switzerland, from Egyptian there is a code, from Canadian code is also available. So right now there is a scope in India also that it is also gaining popularity by using this codes. Now, in India, in the field of the education and research related to the FRP constructions, the various IITs, IISCs, Structural Engineering Research Center, SERC Chennai, FRP Institute Chennai, Indian Society for Advancement of the Material and Process Engineering, and its headquarters in Bangalore, also the DRDO. These are the certain agencies are doing that testing and research work is to be conducted and this to be going on also. The main 5 different companies name which has been written over here, which are manufacturing the standard one FRPs like 5A India Private Limited, Foster Chemicals Private Limited, Krishna Conchem Private Limited, BASF, Sika India. There are lots other names are there. Just for the enlisting point of view, I have been shown over here. Now let me discuss the first case study over here. The case study of the Bhopal, where it is the problem of the old age homes. The consultant was of the Skyline Consulting Engineer. Now here, the project was to be strengthen the columns at the basement level. The name of the building itself, the old age home, we know the function of that one. So now this structures was nearly constructed having a 5 floors and it's just a 5-style old age home has shown the signs of cracks at the basement level columns immediately during the finishing stage of the project. And the standard NDT and the courses were conducted and they finally concluded that the columns have not achieved the required grade of concrete. So just we can see that the how to a construction which has been carried out at the initial stage. So one of the options has been taken care as an FRP to be used, and FRP jacketing which has been carried out at these situations. So finally, with the help of the researchers, use the FRP for the jacketing of a column. The case study number 2 is that of the Odisha Utkal Alumina International Limited. This is one of the chemical pond. Here the project requires the 2 mm thick built-up FRP composite lining with the chemical resistant coating system for the effluent treatment pond. As the size of the capacity which has been shown over here, and here the unidirectional woven glass FRP sheet has been used with the epoxy adhesive. Now unidirectional woven glass means in the longitudinal direction the FRP sheet which has been applied. This is the third case study of the Kolkata Ahimsa properties. Here the strengthening of the column with externally bonded FRP has been used in this particular property. Now, which kind of project is there and what is the project requirement is there? As I discussed that this particular building which is located at the heart of the city, that is the Kolkata, and the project requirement is that the strengthening of the column which is to be required because of the additional loads of a proposed swimming pool on the roof of the building. So after use of so many years, they have proposed to use the swimming pool at the roof of the building. So a huge loads come on the building. So the solution has been carried out as the use of externally bonded FRP material by the confinement to achieve the means of the compressive strength of the RC columns, and they have used certain guidelines. See, in each and every case, they have been used certain guidelines, certain design guidelines, as there is no Indian standard design guidelines, and today is also available. It is not to be available that any guidelines or any suggestions. So they have used FIB Bulletin 14 Switzerland guidelines based on the information. Another case study, that is the strengthening of the underpass at National Highway Raipur Oranson section. See, the image clearly shows the use of the FRP sheets. So It is have to be understood. The another case study is of the Bharti Airtel Data Center, Bhubaneswar, Orissa. Here, in this case, the building which was made in the 2012, and the data center is located at the center of Bhubaneswar, that's Odisha, and due to the technical requirement, the strengthening of the beam, slab, ceiling, columns was to be done to get the additional load of UPS. KD Tower, Baikala, Mumbai. One of the image which has been shown over here. Here the problem statement is there. This particular building which was proposed for additional for another 4-story with existing 20 stories. So building which is of the made up of 20 story and another 4-story which was proposed. So originally the building which was made up with the 20-story building, so the design which has to be carried out for the 20-story to take care of the loads. But when we go for the proposed for the new 4-story, the strengthening of the existing component of the structures to be carried out. So the load carrying capacity of the main columns were good enough to carry the extra load according to the previous Indian code. But according to the revised Indian standard code, the factor of safety or main core columns required to be enhanced, and they find solution which is of the one layer of CFRP applied parallel to the axis of the column to prevent a buckling. Please try to understand that when the FRP sheet which has been applied, it is applied with respect to certain directions when we are using the unidirectional one. As unidirectional one which is having a gaining popularity for the infrastructure point of view. And the 3 layers of the CRP which is applied perpendicular to the axis of the column for the confinement. See the image after the construction of the 4-story. The next is the Century Hotel, Mumbai. Another case study is there. This is the problem of one of the beam. Has been clearly shown that the original depth of the beam, which is of 1150 millimeter, because of a certain reason, they want to reduce the depth of the beam. Means they want to cut it down to 350 mm. They want to reduce the depth of the beam. Means they want to remove the upper portion of the beam so that the upper floor can be used. So definitely as the 2 reinforcement of the top bar which has to be cut down, and along with the depth has been cut down, there will be a drastic reduction in the flexion in the shear strength. So here the solution as shown in the image, that the CFRP which is to be applied at the bottom to increase the flexural strength of the beam, as well as the wrap applied. See the image, the wrapping at the support, near the support. You just see the figure. This wrapping is to be applied at the end of the beam as U wrap to increase the shear strength of the beam. So, and I can just repeat that this is not the arbitrary the things can be carried out. Use certain guidelines, and based on those design guidelines, we have to carry out the design procedure, and systematically we have to use this one in the real application. Certain images as we shown over here. So these are the certain images for the same thing which has been shown over here. Last one case study is about the Chennai Corporation in Tamil Nadu. In India, use the fiber wrap technology maybe 10 to 12 years before to fortify its old civic structures, including the building and bridges against the earthquake. And the fortification techniques has been initiated in the wake of the city being upgraded to the seismic zone 3 a few years ago. Also, the work on the Kodambangam Bridge and Ripon buildings of more than 150 years old has already been completed by the Chennai Corporation. So it is also true that the FRP as a retrofitting material is exhaustively used in India also. So let us explain. Let me explain the FRP application procedure. The first, remove all unsound concrete and loose particles. Then arrest the corrosion. If there will be corrosion, remove that particular part and make it its original shape. Try to grind the corners and make the surface smooth and undulation free. Then apply the adhesive as adhesive made up with the two different components, the primer and saturant, as far as the wet lay application is concerned. After application of the adhesive, press the wrap, that is, press the FRP or strip by hand. Then use roller to remove the intermediate air. Put another coat of adhesive and then apply protective coatings. See certain images. I have a 1-minute video over here to show over here. See the images. The first is the open the pore structure, remove the latents, remove the paints, debris, curing compounds, etc. Make it clear surface so that the contact between the FRP and the older structure will become properly. And this is also the procedure of the alternate surface preparations. See the here, the curved surfaces has to be carried out over here so that there should not be any kind of the stress concentrations will be taken care the connections at the junction. So round corners of the specific radius has to be made it out, and the removing all the imperfections, latents, smooth and level has to be carried out. Fill up the bug holes, pinholes, honeycombs, voids, repair the imperfections and create the even surface. Then apply the priming the substrate. Now, depending upon the manufacturing company to company, certain companies tell us that apply the priming before application of the FRP sheet and carried out the curing of the priming for 24 hours. Certain companies says for 48 hours, certain maybe 12 hours, depending upon the manufacturing company and its regulations that we have to follow during the retrofitting this dynamic purpose. So this priming will create a feasible environment for the FRP sheet for the applications to the older structures. Then applications of the FRP. So now the one image which is clearly shows that the manual wetting. Manual wetting means what? After the curing period of the priming is over, apply the FRP on the structure and then apply the saturant. There is another chemical that is epoxy. Apply that one. So that is nothing but application of two different component of FRP directly at a site. It is the manual wetting is to be applied. And another one, the secondary image which has been shown that automated wet, it means the along with the epoxies and FRP which is ready-made to be done at the factory and the directly applicable, just apply a sheet on the concrete surface. Some of the typical example or applications are there over here, which has been shown certain images. So after applications, the air void has to be removed, that the air voids between the older structures and FRP that has to be removed. And this is the finished product. In finished products, we can apply the coatings for aesthetics, UV protection, for the heat protection as shown in the figure. Now, let us continue over here. Before I will switch to the durability aspect, let me show you the 1-minute video.
Protect
Nirav sir, is it visible? Tandel sir, is it visible? Is it visible? The video of 1 minute is visible. The voice is not there. No, sir, yet not visible. Just 1 minute, hold on. Just 1 minute, hold on. Tandel sir, is it visible?
area by laying down a tarp. Seal pre-existing crack area. Protect area by laying down a tarp. Seal pre-existing crack area. Drill holes to inject resin.
I think just remove that one. I just have to tell
The
you. Now, here, I think my voice is clear. Now, here you can see that there is a wet applications of the FRP which has to be carried out. Let me continue with the durability aspect. Durability concerns, let us continue. Now, the question may arise, what is exactly durability? The ability of an FRP material to resist cracking, to resist oxidation, to resist chemical degradation, delamination, wear, and or the effects of the foreign object damage for a specified period of time under the appropriate load conditions and the specified environmental conditions. So this is the wide perspective that the term of the durability is concerned. Now the word caution has been written on this particular PPT. What does exactly mean? That the data of the durability of FRP materials is very limited. Why? Because many different forms of the FRP available and the fabrications process are available. So we cannot make a common conclusions for certain tasks. So researchers having a very good chances to carry out the research work as far as the durability concern. Also, this data of the durability, which is in certain cases are of the contradictory in some of the cases. Some voices there, Nirav sir, Tandil sir, Hussein, some typical voices there.
Yeah.
Somebody has opened their microphone.
लो हाँ हम तो जो है सजेशन देने वाले हैं कि डिपार्टमेंट को कम से कम 5 फॉर्म भिजवा दीजिए है।
So, FRP used in the civil engineering applications are substantially different from those used in the aerospace industry, so the durability cannot be assumed to be same in both the cases. Now, as far as the environment is concerned, the all engineering materials are subjected to the mechanical and physical deterioration with respect to time, load, and exposure to the various harmful environments. So the FRP materials are very durable and are less susceptible to degradation than many conventional constructions material like cement, concrete, steel, etc. There are certain factors which affects the durability performance. There is nothing but the first is matrix and the fiber type. Because type of matrix changes, the durability concern is also changes. And the fiber types are also makes concern. Just 1 minute. Now, the factors affecting the FRP's durability. The one is, as I stated, the types of the matrix and the types of the fiber which affect the durability performance. We know the matrix type we discussed in the earlier slides. We discussed about the types of fibers also. So the relative portions of the constituent is also affect the FRP's durability performance. Manufacturing process of the FRP also affect the durability. Installation procedure is also one of the factors. The short and long-term loading and exposure conditions are also affect the durability performance. So, what are the issues which is related with the durability of FRP? The one is moisture and marine environments. That is nothing but the environmental effects are concerned we are discussing. The another is alkalinity and corrosion. Third one is heat and fire. The first one is the cold and freeze through cycle. UV radiation, ultraviolet radiation. So these are the environmental effects which affects to the durability of FRP. And another the physical effects are the sustained load, that is creep, and the cyclic loading, that is fatigue. Some of this we are discussing today right now. Now let us take the first one, that is the moisture and marine exposures. FRPs are particularly attractive for concrete structures in most and marine environment, as FRPs are not susceptible to electrochemical corrosion, as the steel which is susceptible for the electrochemical corrosion, but FRP is not. So corrosion of the steel in conventional structures results in severe degradation, but FRPs are not. But even though the research stated that FRP are not immune to the potentially harmful effect of the moist and marine environment. Means certain evidences shows that the linking the rate of the degradation to the rate of the sorption of the fluid into the polymer matrix, which will degrade it to the FRP in certain extent. So all polymers will absorb moisture, and then depending on the chemistry of the specific polymer involved, and that can cause the reversible or irreversible physical, thermal, mechanical, and or chemical changes. So it is important to recognize that the results in the laboratory testing are not necessary that it is indicating the performance in the field. So here the field observations are more important than the laboratory observations. Some of the selected factors which affect the moisture absorption of FRP is the type and the concentration of liquid, type of polymer and type of fiber, fiber resin interface characteristics. Next is the thing with the manufacturing and the application of method. At which temperature that has been applied is also ambient temperature. At stress level is to be applied. That stress level is also to affect the moisture and marine exposure. Extent of the pre-existing damage and the presence of protective coatings are the factor which affect the moisture absorptions. Now, the overall effect of the moisture absorptions, it has to be shown that because of the plasticization of the matrix, which caused by the interruption of the van der Waals bonding between the polymer chains, that reduces the matrix strength, modulus of elasticity, strain at failure, and toughness. So subsequently, it reduces the matrix-dominated properties, and we know that the matrix-dominated properties are nothing but the bond, shear, flexural strength, and stiffness. It will affect one. So this may affect also the longitudinal tensile strength and stiffness, as the swelling of the matrix causes irreversible damage through matrix cracking. One typical, the percentage mass gain versus the time in terms of the years, the figure image shows the moisture absorption trend in matrix polymer. Just clearly see the time versus the percentage mass gain. This is a typical image, shows the strength, loss of strength of typical FRPs due to moisture absorption and with respect to time. So you just see that with respect to time of 5 to 10 years, more or less tendencies remains constant, that is a percentage strength retention shown in the figure. So the no strength reductions in the some lab studies is also there. So here it is important that there is a further research is to be needed about the strength loss because of the moistures and marine exposures. There is certain potential important detailed synergies that the moisture absorptions and along with the sustained stress and the specific elevated temperature that can induces the micro cracking of the polymer matrix. This is one of the microscopic view clearly shows the micro crack which has been generated because of the insertion of the moistures at sustained stress and at elevated temperature. Now, let us see the effect of moistures and marine exposures with respect to the type of fibers to be used in FRP. If we say the glass fiber is concerned, the moisture penetration to the fibers may extract the ions from the fiber and result in pitching and beating, can cause deteriorations of the tensile strength and elastic modulus at some extent. While in case of the armid fibers can result in fibrillation, swelling of the fibers, and reductions in compressive strength, shear strength, and the bond properties. Certain chemicals, such as the sodium hydroxide and hydrochloric acid, can cause severe hydrolysis, and it will be dangerous to the FRP is concerned, specifically the armate fiber. The carbon fibers is concerned very less or doesn't that much affected by the exposure of the moist environment. So if we are taking the concern specifically effect of the different matrix regimes with respect to the moistures and the marine exposure, then FRP can be protected against the moisture absorption by appropriate selection of the matrix materials and the protective coating. If we are taking the vinyl ester, it is currently considered as one of the best to use for preventing the moisture effects in the infrastructure composites. While epoxy is also considered as an adequate, while polyester, there is available researches suggest having a poor performance and should to be avoided to be used. Now, the second important factor of the durability is the alkalinity and corrosion. Generally, the pH level greater than 11 inside the concrete is to be considered that of the higher alkaline environment into the concrete. So that becomes important for the internal FRP reinforcement applications with the concrete is concerned during the application. So here one image has been shown over here, and the pH level of that particular image concrete is greater than 11. Because of the pH level is greater than a certain range, there will be a favorable environment for the alkalinity will be created, and because of that, there is a damage to the glass fibers as far as the reinforcement is concerned. And here it depends on the protection by matrix level as of temperature. As it affects the glass fiber is concerned, but we have to check it out what will be the protection of the matrix on that particular fiber is concerned. So now, degradation mechanism for GRP reinforcement. See the typical image over here. Because of the alkaline solutions that cause the embrittlement of the fibers, GFRP bar, and because of the cracks will be created, there will be reduction in the tensile strength properties that will damage the fiber resin interface also. Now, if we state the individual fiber is concerned and the effect of the individual fiber with respect to the alkaline environment, specifically for E-glass fiber, the strength will be reduces up to 75% in comparison with the initial values, while for AR glass fibers, as the AR suggests, it is the alkaline resistant glass fibers, a significant improvement in the alkaline environment, but definitely we have to use certain high cost in comparison with the E-glass fibers. Armate fibers definitely strength reduction up to the 50% of the initial values, and for carbon fibers very less effective as far as the alkaline environment is concerned. There will be a reduction of the strength up to the 20%. But as I suggested, has been written over here, needed the further research. The another terminology is galvanic corrosion. This galvanic corrosion, which is related specifically the type of the corrosion which is still with the steel. So FRPs are not susceptible to electrochemical corrosion, but certain FRPs, specifically CFRP, can contribute to increased corrosions of the metal components through galvanic corrosion. So the researchers suggest that because of the electrochemical corrosion, it will be affect the FRP, and that FRP lead the higher corrosion to the steel component. So let us understand what is galvanic corrosion. That is nothing but the accelerated corrosions of a metal due to electric contact with the non-metallic conductor in a corrosive environment. Now, the guarding against the galvanic corrosion, the CFRP should not be permitted to come in the direct contact with the steel or aluminum in structures because they lead higher corrosion to the steel, to the metal parts. So if we take the internal reinforcement, then we have to provide the plastic spaces between the steel and CFRP bars so that there should not be direct contact with the CFRP reinforcement along with the steel reinforcement. If we are taking as external strengthening of the sheet is concerned, specifically for the steel structure is concerned, if you're taking the steel girder is concerned, then we have to apply a thin layer of epoxy or GFRP sheet between the CFRP and steel so that there will be a certain intermediate layer is available of GFRP so that the direct contact of the GFRP sheet with the steel can be avoided, and because of that the corrosion, galvanic corrosion can be avoided to the steel. The third important factor, very important factor as far as the durability is concerned, is the high temperature and fire. As I repeat, a very much useful concern about the fire and as far as the high temperature is concerned. Now, the FRP materials, as we know, widely used for the reinforcement. Also, it is to be used for retrofitting, the rehabilitation, and the strengthening purpose for the bridges. For wet layup system is concerned. Also, it is to be used for the outdoor structures. So, when it is to be used for the outdoor, definitely it will be directly touched with the temperature of the sun. So, FRPs have seen comparatively little use in building applications because of the certain reasons. So, FRP materials are susceptible to elevated temperature. Several concerns associated with their behavior during fire or in the higher temperature service environment, and the research shows that the FRP materials are heavily susceptible at some elevated temperature, that is at certain temperature beyond that level if the temperature is increases, it will be affecting much more. So we can take the generalized statement regarding the higher temperature behavior for specific FRP is concerned, but it is true that the elevated temperature will definitely affect the FRP. So here, the larger number of possible fiber metric combinations, and because of the manufacturing methods and applications, the generalized statement cannot be made. Now, there is a one terminology about the glass transition temperature. Let us understand what is TG. It is the midpoint of the temperature range over which an amorphous material like a glass or high polymer changes from brittle state to a rubbery state. This is one of the definitions available from ACI 440. So now, at certain temperature, it reaches, then this particular material changes from its one state to the other state. So, all organic polymer materials combust at the high temperature, and most matrix polymers releases the large quantities of the dense, black and toxic smoke at the higher temperature. So potential problems will be generated of the FRPs under fire, which has been shown with this schematic stage. One of the example typical shows of the internal FRP reinforcement, if the temperature inside the concrete will increase is the TG. What does it mean TG? We discussed over here. TG means glass transition temperature. So if the temperature inside the concrete at the placing of the FRP reinforcement increases beyond certain level, that is T is greater than TG, there will be a sudden and severe losses of the bond will be there. Similarly, if we are taking an example of the external FRP strengthening, and when it is subjected to the fire or a higher temperature, then the particular level, the bond between the FRP and the concrete will be lost. And because of there is no bond between the FRP and the concrete, there is no connection between the two things. And because of that, both are behaving individual. And because of that, the application, that is the strengthening, which has to be avoided, which is cannot to be used as a sign. One minute, please. So now, so mechanical properties of FRPs also deteriorated with the increasing in the temperature. How? Let us see. Critical temperature commonly taken to be TQ for the polymer matrix, and it is temperature is ranging between 65 degree to 120 degree. See, 65 degree right now we can say is not that much high. Yes, it is definitely high, but at certain time in our Indian environment, at certain places the temperature may reach 45 degree or maybe 50 degree. So 65 is not that much far. So TG results in the severe degradation of the matrix dominated part properties such as the transverse and the strength and the stiffness, and finally the longitudinal properties are also affected and the bond is severely damaged. And when there is a bond is damaged, the purpose for which the FRP is to be retrofitted, the purpose for which the FRP to be applied for the strengthening purpose cannot be served. So the tensile strength reductions as high as 80% can be expected in the fiber direction at temperature of only 300 degrees centigrade. And when there will be and fire will be there, this type of temperature definitely achieved within very initial time. So it is important that the FRP component not to be exposed to the temperature closer to or above TG during the normal range of operating temperatures. Now, the degradation of mechanical properties is mainly governed by the properties of the matrix. If we say the carbon FRP is concerned, there will be no degradation in strength and stiffness up to the 1000 degrees centigrade, also to be visualized by the various researchers. But for the glass fibers is concerned, 20 to 60% of the reduction in the strength will be achieved at 600 degrees centigrade for the glass fiber. Repeat, right now, this is only the individual fibers is concerned. As we stated earlier that the matrix is one of the main weaker component as far as the fiber, as far as the fire is concerned, as far as the higher temperature is concerned. For aramid fibers with very lower temperature, susceptible in the reduction strength up to 60% at the 300 degrees centigrade temperature. So this is one of the typical graph which shows the temperature versus the percentage room temperature value. And here it has been shown that the red line of the elastic modulus, blue line of the tensile strength, and black is of the average bond strength reduction. It is clearly shown over here. And you just see the dotted line, it is nothing but the critical temperature, where T is greater than Tg. If the temperature beyond reaches this value, all the three properties of the FRP, specifically for GFRP bars, reinforcement, is drastically reduces, and for the intentions for which it has to be applied has to be removed. It will become null and void. So the use of FRP internal reinforcement is currently is to be not recommended for the structures in which the fire resistance is essential to maintain the structural integrity. Exposure to the elevated temperature for a prolonged period of time may be a concern with respect to solution of the moisture absorption and alkalinity effects. Now, the next one of the parameter is nothing but the cold temperature and the effect of the cold temperature as a durability parameter. The potential, specifically the cold temperature, is potential for the damage due to the low temperature and thermal cycling, and that must be considered in the outdoor applications where there will be a lower temperature regions are there. So the freezing and freeze-through cycling may affect the durability, performance of FRP components through the changes that occur in the behavior of the component material at lower temperature. Also, the differential thermal expansions between the polymer matrix and fiber components is one of the important tasks. So, the cold temperature could result in damage to the FRP or the interface between the FRP components and other materials. It is to be noted that the structure exposed to the cold temperature to the sub-zero temperature may be results in residual stresses in FRPs due to matrix stiffening and different cities, that is the cold temperature environment between the fibers and matrix. So because of that, the matrix microcracking and the fiber matrix bond degradation will be taken care, and they may affect finally FRPs in terms of stiffness, in terms of strength, in terms of dimensional stability, fatigue resistance, moisture absorptions, and blah blah blah. So all these things will be affected because of the exposure of the structures to the level of sub-zero temperature. So increasing of the freeze and thaw cycles, which increase the severity of the matrix cracks, increase the matrix brittleness, it decreases the tensile strength. But however, the effect on the FRP properties appear to be minor in most of the infrastructures applications. The another durability aspect is of the ultraviolet radiation, that is the UV radiations that damages most of the polymer matrices. The effect of the UV on aramid fibers are significant, but glass fiber and the carbon fibers are insignificant. Thus, the potential use of the UV radiation is very much important when the FRPs are exposed to the direct sunlight. When it is to be exposed in the outdoor conditions, the UV is one of the important tasks, because definitely it will lesser damage to the carbon fiber and the glass fiber, but it will affect the polymer matrix resins. The photodegradation means the UV radiation within a certain range of the specific wavelength breaks the chemical bond between the polymer chains, and which results in the dislocation, surface oxidation, embrittlement, microcracking of the matrix. These are the effect of the UV radiation. That is in terminology called photodegradation of the polymer chains, that is polymer matrix. So the UV ultraviolet reduces the surface flows, which can cause the stress concentration. The stress concentration may lead to premature failure, and this also increase the susceptibility to damage from the alkalinity and moisture. Just a minute, hold on. Maybe 1 after 10 minutes, so half an hour. The combined effect of ultraviolet radiation and moisture on FRP bars. Now, let us take the study, some of the study which has been taken care of the effect of ultraviolet rays and the moistures on FRP reinforcement, and we can see that for the CFRP bars, the tensile strength reduces up to 20%, while the AFRP bars reduces 30%. So the protection of the FRP from the UV radiation, it is to be an important task. So in the earlier slide, it has been shown that certain color coatings which has been shown, that is UV resistant paints, certain coatings, certain sacrificial surfaces, the UV resistant polymer radiations which is to be applied, so that for the outer surface, the surface which is comes contact with the direct sun, the particular FRP can be protected. The another one, the terminology, it is nothing but the fatigue. All structures are subjected to the repeated cycles of loading and unloading due to the traffic and other moving load. Thermal effects, that is differential thermal expansion, wind-induced or mechanical vibrations. If we are using as an FRP reinforcement or as a retrofitting technique as a FRP sheet for a breeze, then there will be a traffic and other moving loads will be there, and that creates the durability aspect of fatigue. So fatigue performance of the most of the FRP is as good as or better than the steel, which is to be found out from the various research criteria. So the good fatigue performance of the FRP, which depends on the toughness of the matrix, ability to resist cracking, that depends on the FRPs. So performance of the FRPs in the fatigue load as far as the AFRP is very excellent. For CFRP is best and for the GFRP is good. So we can say that in comparison with the steel, the performance of the FRP for fatigue is very good under the criteria of fatigue. Now, there are certain reductions factor which has been given in the guidelines, federal guidelines, so that this reduction factor can be used while we are doing the design of any structural component with the FRP, so that the durability aspect can be covered. But even though the durability factor, which is remained incompletely understood as on today's date, also the researches are going on, the research is going on. So when you are referring the various researches, then durability is one of the right now very much important criteria. There are certain reduction factors which has been shown over here, given by the code. These factors to be applied during the design is concerned. There are certain case studies which has been shown. That is the thing, but how the field evaluation which has been done. So the field evaluation of any kind of the FRP which has been carried out by the different test is concerned, like optical microscopy, by SEM scanning electron microscopy, by EDS, that is energy dispersive X-ray analysis, infrared spectroscopy, and also DSC, that is differential scanning telemetry. Now, this is one of the individual topics that we can discuss. The two was constant, that how the optical microscopy or how the SEM should be carried out and how the photography of the interpretations is to be carried out. But it is not right now the scope of the task within this time period. But even though the slightly input has been taken care over here, the first, if we take the optical microscopy, here is to visualize or to examine the interface between the GFRP reinforcing bar and the conflict. So here it is to be noted that after 8 years of exposure to the alkalinity, present through cycle, wet, dry cycle, and the chloride ingress, there will be no evidence of damage or deteriorations has been shown over here, or very less damage will be there, which can be visualized from the optical microscopy. SCM, which is useful to conduct highly detailed visual inspection of maybe any kind of FRP. Here the figure shows GFRP, and here it is written with some of the example of the bridge has been concerned with a certain study, and after 8 years of the existing structures with the FRP shows no evidence of the damage. Similarly, the energy dispersive X-ray analysis which has been carried out, and the study has been shown the results over here. Infrared spectroscopy and differential scanning telemetry, this all shows no evidence or damage because of the certain alkaline intrusion. So the important final concluding remarks is that the durability performance of the FRP materials is generally very good in comparison with the other more conventional construction materials, but it should be equally clear that the long-term durability of FRP remains incompletely understood. So large research effort is to be required to fill all the gaps and in knowledge. So what is the part in which the research is to be needed as far as the durability is concerned? Then moisture terminology. Here the effects of undercure and or incomplete cure of the polymer matrix and the effect of the moisture is need to be studied. Effect of continuous versus intermittent exposure of the moistures when bonded to the concrete, which is needed to be studied. As far as the alkalinity is concerned, determination of regional and defensible standard alkaline solutions and the alkalinity testing protocols, database of Durability information need to be studied. Development of an understanding of alkali-induced deterioration mechanisms needs to be studied. So the potential synergies effects of combined alkalinity, stress postures, and temperatures are not well understood, so particularly they relate to the creep rupture of FRP components. So these are the topics in which the detailed research is to be needed. Specifically, fire is concerned, non-destructive evaluation methods for the fire exposure composite needs to be needed for the research area is concerned. Fire repair strategies with respect to the FRP need to be under research. Development of the relationship between the test on small scale material samples at the higher temperature and the full scale structure performance during the fire, which is needed to be studied. If fatigue is concerned, more fatigue data on variety of FRP materials are to be required for the research purpose. So, mechanistic understanding of fatigue in composites in conjunction with the various environment factors are need to be studied for the research purpose. Also, the development of a rational and defensible short-term representative exposure to evaluate the long-term fatigue performance is to be required. So, finally, we conclude that at any stage, the FRP is to be used for the construction purposes, but before going ahead, we should need the study of the design aspect by using the certain coded guidelines, and that coded guideline should meet with our Indian environment, with the Indian context. Also, it is to be needed to go for higher research side on specifically of durability is concerned. Thank you very much for listening me. Now, if you have any questions or query, please welcome. You can ask the questions over through chat box or through the WhatsApp. So participants are welcomed over here to ask the questions. Question: FRP material is stronger than aluminum? Definitely, it is stronger than the steel also. It is definitely stronger. Next question: how can we define different grades and layers of FRP are required? How can we define different grade? Different grades of FRP which has been defined by different codal provision of the different countries. If you are referring ACI, there is a certain provisions, just like we can say that for the steel, there is a 415 grade of steel, for 250 steel is available. We know the various types of the steel grades, and that has been written in our Indian standard codes are also. Similarly, the FRP, its own codes, guidelines given by the different countries suggested their own grades has been shown. Now, layers of FRP is required. Depending upon the strengthening technique adopted, means when there will be a certain structures are there, in certain structure, the retrofitting is to be needed. When there is a retrofitting is to be needed, then we have to evaluate the existing structures with the certain coded guidelines, as well as we have to apply certain guidelines for the FRP, and then we have to find it out the 1 layer is sufficient, 2 layer is sufficient, or maybe 3 layer is sufficient. So depending upon the design aspect, we have to go. Is any other questions from the participant? Let's wait for 2 minutes. If you have any questions, you can raise over here at this platform. What is the cost of 1 square meter in normal condition? See, if you want to procure the GFRP as a sheet of a one roll of 1 meter width, And if you want to purchase a simple single roll of 50 meters square, it may be a cost from different company to different company. In certain cases, it is applicable for 10,000 rupees. In certain cases, it costs 40,000 rupees also. Now, along with you have to purchase, because we are right now discussing about the restrengthening, that is the retrofitting is concerned. So we are discussed with the only with the FRP sheet is concerned, and then you have to also purchase the epoxy, and in which the two different materials are there. These and that is the primer, and as well as the epoxy, that is the hardener that we have to purchase, and their cost is also individual company shows different one, because the curing period is also different one. So in general case, if you purchase a 50 meter square roll with along with the material, with the average cost around, it will be applicable of 20 to 25,000 directly available. But I will say 50 meter square roll is concerned. 1 meter square, we have to find it out. I can't say directly right now the exact answer. Any other questions, please, sir? Yes, sir. Eager to PPT, but sir, right now only I have my own PPT. Will share with you. But other the three PPTs which the three lectures has been conducted, I am concerned with the experts. I am telling him directly to give me so that I can give you. As and when they will give me, I am going to share with you. What about the bond strength of the properties of FRP? See, the bond strength having own issue. The bond will generally governed by the matrix is concerned. Bond which is governed by the matrix is concerned, as I discussed with this PPT also. Very good bond will be available if it is not exposed to the severe environmental condition. It having a very good strength bond. Yes, definitely. In circumstances, certain circumstances, certain an extra load, there will be a debonding problem will be generated. But nowadays, the problem has been solved by providing the anchoring, by providing anchorages. The problem has also been solved. Okay. Now, is there any questions? So there are no questions from the participants. So final remarks. I'm thankful to all the participants to listen me very carefully. Any kind of questions you may arise, you may directly ask the questions through WhatsApp also. So finally, this session has been handed out by myself. The another session will be started from 1 o'clock. Professor Dr. Katta from NIT Suratkal, they will take care of this session. And as I stated earlier, today's session, which has to be taken care by Modera sir, but as such, another question is that I would like to give you the answer. As such, he right now the out of station, so he told me to take care of the lecture on Thursday, first one. So today's last session, which has to be carried out by myself, that will be carried by Dr. Tandel sir. Next question is, how can I find anisotropic property of FRP sheet if we only know the young modulus of FRP? Very good questions has been asked by the participant. The test has to be carried out. The test has to be carried out with the, we have a various, would like to give one simple answer. Cement, we know a coral provision, how to carry out the testing. How to carry out testing for the steel, we have a coral provision. Similarly, how to carry out the testing for tensile strength, for young modulus, even for compression, the coral provisions are available, not for Indian standard, from ACI, of other countries also. You just follow that procedure, find out the strength. Now the question of anisotropic, yes, definitely. When you provide, if your FRP of unidirectional, then your intention is to find out the strength in that particular direction only. But when you are using bidirectional, then carry out the testing in bidirection and find out the strength. You can find it out. I think my answer will be satisfy you. Even though find any questions, you can ask the questions. No questions? So I'm going to relieve you. We will meet at 1 o'clock. No, there is, as I stated, I'm also awaiting for this. There is no Indian standard code. There is no such guidelines which is available. So whatever the repairing strategy, what is the application of the FRP bar and FRP as retrofitting technique which has been used, it is based on the foreign codes or foreign guidelines are only there. Yes, definitely we'll share the PPT. Through generally, I am sharing the PPT through the email, because last time or in the previous time also, because this is the fourth FDP we are organizing with the same department by myself. So every time I'm going to share you the PPTs, the materials through email only. Fine. Thank you very much to all the participants. We'll meet at 1 o'clock.